In this video, we're going to talk about our basic exponent rules. This is going to be a pretty short video because there aren't a lot and they're pretty quick. Exponential form versus expanded form versus standard form. So these are the three different ways you can see these expressions written out. Exponential form is kind of like the most simplest form, okay? If it's x to the fourth power, it's just literally written x to the fourth power. We could also say it's x raised to the power of 4, okay? Now keep in mind some exponents have different names or ways you can say them. For instance, x to the second power or x raised to the power of 2. We often call this x squared. X to the third power also has a special name. We call that x cubed. But those are the only two that have special names. Everything else after x to the fourth is just called x to the fourth, x to the fifth, x to the sixth. You could say it all, x raised to the power of 4 or x to the fourth power, but mostly you're going to hear people just say x to the fourth. Expanded form would be if I took something like x to the fifth and I actually wrote out how many x's that was that's being multiplied together. So x times x times x times x times x, 5x is being multiplied, that is x to the fifth in expanded form. And then standard form, this only works if your base is an actual number that you know. Okay, so I couldn't take x to the fifth and put it in standard form because I don't know what x is. I don't know what to multiply by itself 5 times. But here I do know that I'm looking at 2 to the fourth. So this is 2 times 2 times 2 times 2. That is just the number 16. Okay, so standard form would be actually taking it, and if you can simplify it because you know the base, giving me the simple version, 16. The 0 rule, I love this rule. Any number raised to the power of 0 is just equal to 1. So 3 raised to the power of 0, 1. 15 raised to the power of 0, 1. Any number you can think of raised to the power of 0, always 1. And the first power rule. Any number raised to the power of 1 is just itself. So 3 to the power of 1, it's basically saying, hey, take 3 this one time. Okay, there's 3 one time. 15 to the power of 1, that's just 15. X to the power of 1, that's just x. And that's why in other videos you'll hear me say, oh, you have this x by itself. Well, remember, there's really an invisible 1 hanging out there next to it. That's why, because anything to the power of 1 is just itself. Now the negative exponent rule, we're going to briefly touch on this, and we're going to really get into it more in another video. But negative exponents are not really allowed in simplified expressions. Okay, so 3 to the power of negative 4. We're not supposed to leave our simplified expressions like this. If you've already seen my video on multiplying exponents and raising a power to a power, you'll know that I broke that rule and I left the negative exponents in my final answer, because some of you aren't going to have seen this video yet. So I wanted to make sure we talk about, well, what does it mean when there is a negative exponent? Okay, so 3 to the negative fourth, what that actually means is we're taking 3 4 times, but we're dividing it. So we can make a fraction out of this. Right now, this is 3 to the negative 4 over 1. I can turn the exponent positive by moving across the fraction line. So right now, 3 to the negative fourth is, we're going to call it upstairs. If I move him downstairs, now he is positive, 3 to the fourth power, okay? Since there's no numerator left, I have to show the number 1. So 3 to the negative fourth is the same as 1 over 3/4, okay? This is going to be a lot clearer when we do a whole lesson on negative exponents. N to the power of negative 7, that's just 1 over n to the power of 7. 1 over b to the negative fifth, so it's kind of opposite. B to the negative fifth is in the downstairs part of the fraction. I need to move it across the fraction line, so he's going to move upstairs, and now he's going to be a positive exponent. And I don't have to write the over 1. I can if I want to, but I don't have to, because I don't have to show a denominator, whereas I do have to show a numerator, like in the first 2 problems. And that's that. Let's do a couple of practice problems real quick, just to make sure we understand this concept. If you had 3 to the power of 0, that answer would be 1. If you had 57 to the power of 1, your answer would be 57. If you had 6 to the power of 0, your answer would be 1. If you have 5 to the power of negative 3, you would simplify that to 1 over 5 to the power of 3. If you have n to the power of negative 7, you would simplify that to 1 over n to the power of 7. If you have b to the power of negative 3, you would simplify that to 1 over b to the power of 3. If you had 1 over c to the negative 3rd power, you would move it across the fraction line. Now it's upstairs, and it's c to the positive 3rd power. If you had 1 over 3 to the negative 7th power, you would move it across the line, and it would come up to the numerator and be 3 to the power of 7, which we could figure out. And lastly, if we had 1 over x to the negative 16th power, let's just go something crazy. It's just x to the power of 16. So those are our basic exponent rules that you're going to want to know.